Now let us have remaining curves. So let us go for the second cycloid. Second cycloid, what in similar way you can have third cycloid, minus, plus, fourth cycloid. Now you might have observed that at every cycloid we are having cusp. What is cusp? It is a double point at which what two tangents are coinciding with each other. Now let us go for this curve. This is called the tractrix. Equation of tractrix is x equal to a cos t plus 1 by 2 a log tan square t by 2 y is equal to a sin t. So if uh, by putting t is equal to minus t, okay, you will find that x is even, y is odd. So if you put t is equal to minus t, tan of minus t by 2 is minus tan t by 2 bracket square is plus, so log of tan square t by 2, and cos of minus t is cos t. Therefore x is even and y is odd. Therefore this curve is symmetrical about x axis. Okay, so x is even, y is odd. Okay, means what, for checking symmetry about y axis you are supposed to go for the second point. What is that? Put x equal to what, pi minus t, and you will find that by putting x equal to what, pi minus t, y has same value whereas x has equal and opposite value. That's why this curve is symmetrical about what, y axis also. So here we have what, both symmetries. So you might have observed that in my previous lecture I even reiterated that this curve is symmetrical about both the axes. Which curves? Out of 6 parametric curves, okay, 4 are cycloids. All 4 cycloids are symmetrical about y-axis, and remaining 2, that is tractrix and your asteroid, they are symmetrical about your both axes. Okay, so in examination you may directly write, okay, if it is tractrix it is symmetrical about both, if it is asteroid it is symmetrical about what, both, and if it is cycloid it is only symmetrical about what, y-axis. Okay, now find out dy by dx value. Okay, so find out dy by dx value. So finding dy by dt is very easy. Finding dx by dt is complicated. So find out dx by dt. Dx by dt, yes, will be like this. Okay, so derivative of cos theta is what, minus sin theta. Okay, so 1 by 2 as it is. 1 by 2 as it is. Okay, so this 2 and this 2 will get cancelled. So log of tan square is 2 log tan, and 2 cancel. So we get log tan t by 2. And derivative of log of tan t by 2 is 1 upon tan t by 2 into derivative of tan t by 2 is sec square t by 2 into derivative of t by 2 is 1 by 2. Okay, and then if what we take this sec square t by 2 into denominator, we get 1 upon what, cos square t by 2, and tan t by 2 is sin divided by cos. 1 cos will get cancelled, we get 2 sin t by 2 cos t by 2, and see this what, 2 sin t by 2 cos t by 2 will form sin t. Okay, so we get dx by dt, what, a inside the bracket minus t plus 1 upon 2 sin t cos t, and 2 sin t by 2 cos t by 2 is sin t. So we get minus sin t plus 1 upon sin t. If you take LCM, we get what, 1 minus sin square t in numerator divided by sin t, and 1 minus sin square t is cos square t divided by sin t. Okay, if you take what value of dy by dt is simply from this a sin t derivative is a cos t. So take a ratio, what, 1 a cos t will get cancelled. So what remains, sin t divided by cos t, that is equal to tan t. So what, see, even though we have lots of complications, the value of dy by dx is very precise, and that is a tan t. Okay, now make table of values of what, t, x, y, and dy by dx. So for which what, 0 to, for which t varies from 0 to 2 pi. So x is equal to t is equal to 0. What is x? Infinity, minus infinity. Y is 0 and dy by dx is 0. X is pi by 2. So you will observe that what, x varies from minus infinity to plus infinity, that is x is unbounded, whereas y is fluctuating in between 0, what, in between minus a to plus a. So you can see that what, x is equal to plus a minus, that is fluctuating. So you get what, a shape like this, and that is called your tractrix. Okay, note that values of y are bounded in between minus a to plus a. Okay.